Hi everyone. Have you ever wondered how people used to get around before GPS? Or maybe your phone died somewhere and you need to know which way to go? Well, it turns out the sun, the moon, and the stars can all tell you by means of star navigation. It's this ancient practice that goes across all civilizations, even in space on the Apollo missions. It's using the sun, the moon, and the stars to figure out where you are on the earth and how to get to where you want to go. And so there's a ton of techniques to doing this. The one I'll talk about today is how to find your latitude, which is how far north or south you are of the equator, using a noon sight of the sun. So to understand what this looks like, I'll show you a globe. So let's pretend I'm here in California, and this angle between me and the equator is my latitude by definition. And at noon, the sun is actually between me and the equator. And so the basic theory is, if I know the angle between me and the sun, and I know the angle between the sun and the equator, I can figure out the angle between me and the equator, which is by definition my latitude. And so I only need to know two numbers. This first one you measure, and the second one you look up in a table. So let's talk about them in turn. Okay, so the first number we need is how high the sun is above the horizon at noon, which corresponds to that angle between me and the sun. So as the sun travels across the sky, rises in the east, reaches a maximum height at high noon, and then sets in the west, we want to measure that maximum height at noon. And so to do that, it's an angle above the horizon. So we do it by measuring, just like any other angle, we'd use something like a protractor. And that's exactly what we do. So we use this little device, I like to. It's called a quadrant. It's a quarter of a circle and it's marked with the degree markers just like a protractor. It has a plumb bob, so it hangs with gravity, and a sighting tube that's hollow, and I can look at a star through it. And so when I look at a star through the sighting tube, you can see that I actually, the angle that I'm tilting up to see it is marked on this plumb bob. And I can read that plumb bob and figure out what the angle is above the horizon. Now, the thing is that we actually want this angle. It's the angle between the zenith, which is the point directly over your head, and the sun. So, but to get it, it's pretty easy. You just take 90 degrees minus this angle, which is the height of the sun above the horizon. You get that zenith angle. So 90 minus this is equal to this. And that angle is this angle between me and the sun. Okay, so the second number is the angle between the sun and the equator. Now it turns out, just like you can map the Earth's surface with lines of latitude, you can actually map the surface of the stars in the sky with lines of declination. So declination is how north or south stars are in the sky. And it turns out that every star has a value for this. The sun and moon change this value every day because of the seasons and the Earth's orbit, but you can look up in a table. It's very simple. And so you get this number from the table at the time of your sight, and that's your second number. Okay, so now we have these two numbers, and as a reminder, on the globe, that looks like the angle between me and the sun, and the angle between the sun and the equator. If I want to know my latitude in this case, I just add the two numbers, this number plus this number, and that's exactly what you do. Even if the declination happens to be negative or south, you just add this number, and you just add a negative declination, so no problem. The only other situation is when you are between the sun and the equator, in which case you take the angle between you and the sun and you subtract it from the angle between the sun and the equator, in which case you get this distance, your latitude. But it's pretty easy to figure out. Just think about it on a number line or something. Anyway, that's how you find your latitude. And so here's a quick example to show you what I'm talking about. All right, so let's do a quick test to see if this works. So I have the quadrant here, and the sun's over there. It's a little bit afternoon. And so I'm going to make the sun go through this sighting tube and light it on my hand like this. And you can see, when I get it right, we read on the value 34 degrees. So we use that as our first number. Okay, so the second number we need is today's declination for the sun. So we're going to use an online nautical almanac. You can see here, you have the sun, you have today, Monday, and the declination of the sun is at 1 o'clock, it's south 21 degrees. Okay, so I got those two numbers. Here's what they look like on a globe. So the angle between me and the sun, I measured it as it should be 90 degrees minus the height that I measured, which is 34 degrees. That's 56 degrees, so that's this angle. The angle between the sun and the equator was south 21 degrees, so negative 21 degrees. And then all I do is I take this, I subtract this, and I get this, which is 35 degrees. All right, so I hope this was helpful. Let me know if you have any questions. Happy stargazing.